Traditional code functions through explicit step-by-step instructions. It expects predictable inputs and executes them in sequence. A vague objective, like ship the release notes and announce it, shatters that rigid logic because the software has no path for the unexpected. Deterministic software fails when it encounters missing data or ambiguous context. Without an explicit instruction for every possible variable, the system simply stops. We are currently seeing a change in how we interact with computers. We are moving away from providing exact instructions and instead giving machines high-level goals. Building software that can handle these goals requires a new type of architecture, one designed to adapt to the environment in real time. The engineering solution to this problem is the autonomous agent. To understand the mechanics of these systems, we are looking at the framework established in 30 Agents Every AI Engineer Must Build by Imran Ahmed. Intelligent agents do not process data in a linear, one-way pipeline. Instead, they function through continuous cycles of feedback. This is the cognitive loop, the internal system governing an agent's behavior. A central cognition core connects to specialized modules for memory, reasoning, and planning. Bidirectional feedback pathways coordinate signals across every module, turning a static tool into a dynamic entity. Consider the prompt, "Plan my trip to Tokyo next month." To a traditional program, it's just a text string. To an agent, it's a multi-stage objective. In the perception phase, the agent extracts context to build an internal representation of the world. It identifies Tokyo and next month. Moving to reasoning, it determines why this data matters, flagging missing variables like preferences for further investigation. Together, these two phases transform ambiguous human language into a structured model that the machine can use to make decisions. Next is the playing phase, where the agent performs task decomposition. It fans out the high-level goal into concrete subtasks, searching for flights, checking visa rules, and selecting hotels. This involves an engineering trade-off in granularity. Large subtasks are harder for the agent to verify, while subtasks that are too small create unnecessary computational overhead. Finally, during the action phase, the agent executes these steps by invoking external tools and APIs to retrieve real-world data. But what happens if an API times out or a selected hotel is fully booked? Suddenly, the plan meets a hard digital roadblock. Instead of failing, the agent enters the learning and feedback phase. It replans from its current state, keeping the work it has already finished and generating a new strategy to bypass the obstacle. Assessing a failure and modifying a strategy without human guidance, this is the technical definition of autonomy. This is the Agentic AI Progression Framework, which categorizes systems into 5 levels of maturity. While simple bots occupy the bottom tiers, mastering the cognitive loop allows agents to reach level 4, where they handle long-horizon planning and learn from interactions. Organizations using level 4 agents move beyond simple automation. By handling the iterative work of research or fraud detection, these systems extend the strategic reach of the humans who oversee them. The cognitive loop provides the conceptual foundation for building these systems. To see how these principles are applied in production, you can explore the 30 different agent models detailed in Imran Ahmed's book. Subscribe to neurals.ca and visit our website for more deep dives into agent architecture. The shift toward agentic architecture changes the relationship between human intent and computational action. We are moving from software that executes static instructions to systems that perceive, reason, and adapt to reach their goals.